Welcome everyone. My name is Giacomo Beccari, and I welcome to the last day of our intense workshop on ESOGPT and the use ESOGPT24, which is on the use of GPT technology and LLM technologies in astronomy, and with a diverse set of point of view. Of course, we have explored several aspects during the past days. We went from a technical aspect to the application in astronomy, so the technical aspect with the help of computer scientists, then to the details of astronomical use. Then on the third day, we went with the help of cognitive psychologists. We tried to explore the impact of the LLM and GPT models in our life and in our, let's say, on us as human being. And yesterday we looked at the impact of the use of this technology on hiring processes, evaluation processes, on paper writing, also on writing in general. And this is basically the topic that we are going to cover today. We are going to see the details a bit of impact of how, when we use these tools on writing papers, what are the consequences, what's the status of today of this aspect, and with this I would like to basically just remind you the conference is hosted on Zoom and broadcasted live on YouTube. All the previous episodes that are posted on a playlist. I've seen that there have been a lot of views after the meeting, while the meeting happens live and live streamed. I see that a lot of people are also watching this later because we have the statistics. Really thank you for the participation. Of course, if people on Zoom, please be aware that you are going live on YouTube. So if you are uncomfortable with that, we fully understand, but we ask you to please leave leave the Zoom chat, and you can go on YouTube and watch still live. For people on YouTube, please feel free to use the live chat to intervene, to make questions or comments, to send comments to the speakers. And with that, and then of course, as always, I remind, this is as an ESO employee, we at ESO, we value respect and inclusion. So everyone is welcome to make questions, especially early career scientists. But of course, we like to have, as it happened, actually a very nice environment where every opinion is absolutely welcome with respect. But I have to say, this conference has been really a pleasure to attend, and it was really beautiful to see all the very engaging discussion that we have had so far. With that, sorry, I took a lot of time, so I will let Henri, my colleague Henri Boffin, who is also a co-chair of the conference. So thank you, Henri, for all your help and all your work. And today you're going to chair this last day. So the floor is yours.
Thank you very much, Giacomo. And indeed, thank you to everyone to join us today for the last day of this workshop, which has been really a fantastic week where we have learned a lot. And I'm sure that this will also be the case today, because we have a wonderful set of speakers for this afternoon. So my name is Henri Boffin, and I work at ESO with Giacomo, and I will chair this afternoon session. Today is about the impact of LLMs in publishing, as well as the ethical questions that this generative AI is bringing to society, but also to the way that we are doing science and astronomy in particular. So our first speaker is Dr. Mei Chiao. I hope I pronounce your name correctly. Dr. Chiao was until very recently the chief editor of Nature Astronomy. After working in radio astronomy with the James Clerk Maxwell Telescope Group in Canada, she went on to obtain a PhD in 1999 from McGill University in low temperature physics. Dr. Chiao is now working for Nature Review Physics, and she will talk about Nature Portfolio views of chatbots in scientific publishing. May, the floor is yours.
Thank you very much, Henri. Yes, welcome everybody. And I'm going to talk to you about what's happening on the publisher side. So is that looking proper on the screen?
It's perfect. Yes, thank you.
Okay, good. Sorry, I had some technical issues due to a power cut. But I'm very happy to be here. In fact, I've really enjoyed the conference all week. There have been some really fascinating discussions, and some of it, you know, I've absorbed, and I think hopefully we, as publishers, authors, reviewers, the whole community, that we can move forward together with, you know, all this fancy new technology. So without further ado, I will. Right, so just very quickly about myself. I've spent more than 20 years at Nature. I started in 2003 as a manuscript editor, actually doing all things optical, you know, photonics, and also nanotechnology and other things. And then, don't know if you're aware, but in 2005, we launched Nature Physics, and I was part of that launch team. And in 2016, I moved over to launch Nature Astronomy, which came out in January 2017. And I've just recently, a few months ago, downsized to work part-time. I'm at Nature Reviews Physics, where I still look after, you know, the astrophysics and almost any other area of physics, mainly condensed matter. With the other half of my time, I'm now doing a master's degree in public policy. So in that time, I've seen quite a few changes. Digital access has been incredible. When I arrived, we didn't even have, you know, digital copies of old Nature. So we've launched many new journals. We've seen so many new submissions, and concomitant reviewer workload as well, and a proliferation of policies, especially with advent of ChatGPT. First, I'm going to say, I'm going to take it as read that, you know, we all agree technology is an amazing thing. So mainly, I'm just going to focus on the publishing side, both, you know, because it was exciting for us editors, but also for authors and reviewers, and, you know, the publishing company at large. So I just wanted to touch on all these basic things because, you know, there are so many headlines screaming out, you know, even the CEO warns us there are risks. There are all sorts of scandals with, you know, things being written by ChatGPT, people reviewing using it. Has it even changed the way we write? And, you know, there's so much going on. So I just want to take a step back and go through this logically. So first of all, I have to say I was very excited when, you know, ChatGPT, I guess, was it 3, burst onto the scene. So I thought, what can it do for me? Can it write my editorials for me? So I asked it to write a short editorial, and that was an interesting exercise. I asked, please, by the way, I am very kind. That discussion the other day was extremely interesting. I always say please and thank you. I asked it, please tell me what are the most exciting astronomical advances for 2023. So it came up with the following. It predicted the launch of JWST, which of course had already happened, although that was the end of its training period, so I can, you know, I can forgive that. It also said OSIRIS-REx will arrive at Bennu to collect a sample of the asteroid, but that was, you know, even a year before JWST. It also predicted a manned mission to Mars, which, you know, we're all still waiting for, and the potential discovery of exoplanets. I mean, yeah, that's true, but kind of a safe and very bland prediction to make. And it also said the EHT will finally observe a supermassive black hole, even though it had happened 2 years before the end of the training period. So, you know, it's not terribly accurate. And I think it shows that the weighting of information is such that it's just not aware when actual things happen, if there's been a lot of buildup and preamble in the media, especially. So are editors actually any better than machines? I always like to show this slide when I talk about publishing in Nature, because it reminds us that to err is human. So these are some of Nature's greatest hits. You know, the discovery of the neutron, we published that. Structure of DNA, demonstration of the laser, magnetic resonance imaging, polymer LEDs, and of course, the first planets around a sun-like star. But we don't tend to publicize the other things. The Krebs cycle, which of course is the citric acid cycle that in all organisms takes sugar and converts it to energy, and that was rejected without review. Beta decay was rejected. We published Pavlov's obituary while he was alive. And sadly, when he did pass, there was only a one line because we had already published a full-page obituary. There was a paper on the memory of water, which was very controversial, never reproduced. Scandal after scandal, you know, multiple retractions. I'm sure there are many more, but I won't dwell on that. Just to say, we're pretty clear that, you know, humans are not perfect. So what can we do then in getting AI to help us with our decisions? First of all, we have some guiding principles at Springer Nature, and I have to say they underpin our policies, but they're also really, really fast moving because it's, you know, the area is changing so quickly. So what we want to do is make sure that, you know, we maintain absolute fairness and equity. And the main message I'm going to give today repeatedly is transparency and accountability, because those are very important. And with privacy and data governance, you know, we really have to respect the laws, such as they are. And I will illustrate these examples as I go. So, chatbots for editors. Obviously, there are many things that could help. So what can we use ChatGPT for in an editorial capacity? Checking background concepts, yes. You know, you can say, oh, remind me what, you know, what's the difference between the R process and the whatever. That's, you know, useful. Finding alternative wordings, of course, but, you know, use with caution because they're not always better. And what about summarizing a manuscript? You know, can I be lazy and take the copy paste the manuscript into ChatGPT and say, tell me what this is about? Well, no. And why is that? Because the submitted manuscripts are confidential, and some of them can contain sensitive information. You can't just plonk them into ChatGPT because then they become public in a sense, and they will be serving to train, you know, further train the platform. So it's the other thing is that the more unpeer-reviewed stuff you dump in, then that again that adds to the body of work that it then builds on. So there are so many reasons why we cannot use an open system like ChatGPT to do our work. And can we generate images for editorial use? No. And again, this is because, well, DALL-E and other such programs were trained on artwork and photographs without, you know, the creators or owners' consent. And there's also question of privacy, because apparently they can create images that look like recognizable humans. And so there are all sorts of, you know, legal and copyright issues, ethical issues that we really have to be careful about. So how common is it then in the scientific literature for authors? This paper that came out in March looked at 45,000 plus abstracts from over 300 journals that were published in the quarter right after ChatGPT burst on the scene. And it found that ChatGPT was involved in 58% of the abstracts in the Lancet and more than 50% in Science. And in fact, for the Lancet in Science, most of the authors were US and UK based. I mean, I think they just looked at the affiliation of the first author. Although in general, in other journals, authors from China really dominate that usage. What about changing word usage, for instance? In fact, I see one of the other talks in this session uses the word delve ironically as well. So this is a really interesting study I found on the archive. And they're looking at how has language changed with ChatGPT. So they looked at 14 million abstracts over the past 15 years. And in the last year, 10% of those had clear, a large language model. I use these words all interchangeably. And about 30% of them in certain topics. So in the plot I put here, sorry if it's hard to see, but you can see words like delves, crucial, potential. These I find puzzling. Why these? Is that as opposed to those? I don't quite understand. The word significant has gone up, but then important has gone down. And so they compared it with other words that, you know, have kind of really been like large major events like pandemic, Ebola, and you can see they go up, they come down. But for these other words, they just go up. And so that's going to lead to a compounding of the use of this flowery and largely meaningless language, you know. What does it mean when you say like, oh, a comprehensive grasp of the intricate web between this and that, and comprehensive chapter delves into their involvement as, you know, it's really bad if we all go down this road. So if you want to extrapolate to the really absurd, can we remove the scientists from the science altogether? So this paper came out a month ago. It's an experiment involving something called the AI scientist. And so the authors had the AI scientists do independent research. So go away, read everything relevant about, you know, this topic. And of course, they could only look at machine learning papers and then come up with some new ideas and then compare them with what else is out there just to find something that's novel, write the code, execute the experiment, you know, plot the results, write the paper, and even more, review the paper. So in fact, they found that overall, it did come up with some interesting things, but mostly the advances were incremental. But then the thing is, you can iterate over and over and over. So, you know, it's a very interesting experiment, but and it's worth pursuing and seeing how far we can go with this. But at this stage, they found, you know, some drawbacks. It struggled to compare the magnitude of two numbers. You know, this thing small children can do, but somehow a computer can still struggle. It hallucinated experimental details. I mean, it literally just made them up. And it would always put a positive spin, even if the outcome was negative. So the only good thing at the very end, well, it's really cheap. So it's an interesting exercise. So, you know, it'll be worthwhile to pursue. But in the meantime, I think we still need people. And so what can authors do? Just to be really clear, when it comes to writing papers, well, AI is a tool. And like most tools, you know, they can be used, but, you know, it's like if it's a hammer, you still need the hand. So it cannot be held accountable And when we have, authors, submit papers and say, yes, I wrote this paper and it's, my original idea, etc. Well, an AI tool cannot be accountable for those things. We really need a human to do that. But what about copy editing? As I already mentioned, it's very good at editing for grammar, spelling, punctuation, even tone. And I think they can even check logic and things like that. And tedious bits of formatting. So yes, it can do that. And if authors want to use AI for editing purposes, that's absolutely fine. And they don't need to be declared in the manuscript itself. What we do ask, though, is that if your AI tools are used anywhere else, then they should be declared either in the main manuscript or in the methods section or the acknowledgements. I mean, the point is just to be, quite open about what you've done. Okay, so on to reviewers then. A lot of these will be similar issues as before. This was an interesting experiment by data scientist Mike Thelwall. He trained a custom ChatGPT, so like a closed model on 51 of his own papers, and asked it to generate referee reports. And apparently the reports were quite, reasonable, and he thought they were totally plausible, and it was difficult to tell whether they were made by a human or a machine. But then the real test is, what would it do to a paper that wasn't part of the training? But even more interesting, I found this really funny. He's like, well, what happens if I just take one of my own rejected papers? He substituted, every time the word male was used, he used squirrel. For female, he substituted human, and for human, he put and gender to species. So with that, the ChatGPT thought it was actually a very good paper and scored it highly, even though it mentioned squirrel surgeons on multiple occasions. So it wasn't able to pick up that a squirrel surgeon is slightly odd. So, it's just to demonstrate that while the tool can do certain things quite well, other things that seem quite simple and basic, it can't do. And so in a bigger study where, more than 300 researchers looked at manuscripts and compared, reviews between humans and machines, they decided, well, actually about half of them said they would use that for reviews, but compared to human reviewers, most people thought that the AI feedback just wasn't quite specific, and so it wasn't as helpful. So again, this is an area that needs developing, but obviously we should proceed with our eyes open. So for now, the policy is, can I use AI to summarize the paper for me? For instance, if I'm asked to review a paper, can I just copy paste it into ChatGPT? No, just like the same as editors can't do this, reviewers can't do this, because for the same, copyright, privacy, security, and confidentiality reasons. Can I use AI to write my report then? Well, no, because, as a reviewer, you have responsibilities that, you need to assess the validity, rigor, credibility, and a computer just cannot do that at the moment. But can I use AI to finesse? Yes, you can use AI to improve your review. In fact, I even read somewhere that somebody types in bullet point what they think of the paper, and then the report gets generated. I mean, I wouldn't do it that way, but I think that's probably okay, as long as the ideas that went into the report came from a human. Do I need to declare that I've used AI then? No, not if it's just for editing purposes. And what if I suspect the authors of using undeclared AI? I think the best thing is just to notify your editor. And your editor probably will then go to their, editorial director or someone like that. But the point is, we can work on it together. So if you notice anything, please flag it to your editor. And so what I want to make sure is that it's clear that it's we view technology as a very positive thing. So at Springer Nature, we're trying to do this intelligently. And so instead of going big, we're going small, as in we take a closed ChatGPT-like interface and we train it on just validated content. So instead of here's the internet, you know, it's more like, well, here's a section of the internet that we trust, and then we train it that way. So there's a program called Curie, which helps authors improve their papers. And this is, I think, quite integrated already in some of the journals, and they're piloting that and will be rolling out to other journals in due course. Ask Addis has been trained on just pharmaceutical drug development literature. So again, this is aimed at a particular community, but I can see, you know, specially designed tools for special communities, and then you don't have to worry about, you know, the garbage in, garbage out problem. So we also have some AI detectives to see if something's gone wrong. So Geppetto is it detects AI generated content. As far as I understand, it looks for consistency between sections of text, like, you know, do they hang together, or they're just, you know, random things from, you know, that don't make any sense. And in fact, Wiley had a pilot that actually flagged 10 to 13% of their submissions as potentially, you know, fake. So paper mills really are a problem that we have to combat. And then Snapshot is another tool that checks images for duplications. So, you know, we use AI to detect AI, but then there's, you know, then it's just, it's always like one up. So, and what can we do? There's, coming to the end, I just wanted to say there's a new tool that we're experimenting called Springer Nature Augmented Insights tool. All it means is that we're wondering if it can write little research highlights as good as we can. So the editor chooses a paper, because I don't think we can tell ChatGPT to go select a paper based on, you know, its interest or significance. That would be very hard. So we choose a paper, then the AI tool writes the first draft, then the editor then checks and edits. For now, the feedback seems to be, it's good at summarizing and producing short highlights, like maybe 150 words, but longer ones tend to be a bit vague. They lack depth and nuance. So for the moment, humans are still better at, you know, evaluating quality, writing interesting things. But the key always is to use AI transparently. And so if we do that, this is, I think, for 2 Nature journals so far, it will show that this has been done with the help of AI. So take-home messages then. ChatGPT and other generative AI tools can obviously help us work more efficiently. But, you know, don't include personal, sensitive, or confidential information. And always remember that accountability and reproducibility are key. Because even if you take ChatGPT and you enter the same prompt several times, you don't always get the same answer. So as authors, please don't use AI to write papers, but editing is okay. Referees should not use AI to referee papers or write reports. Again, editing reports is okay. And don't use AI-generated artwork unless it's specifically writing about AI-generated artwork. And also be transparent about the use. So with that, I'd like to say thank you for your attention, and I'm here for questions if you have any.
Thanks a lot, May. This was great. I mean, clearly you showed how the chatbot can be used across the whole chain, and what should and what should not be done. So I think this is really a wonderful presentation. Thank you very much. Are there any questions for me? I just remind that you can ask questions in the chat either on Zoom or on YouTube, or you can raise your hand on Zoom. And if you prefer to be anonymous, you can also use a form which is on the website and send us an email, and then we will not tell your name. So I see Andres. So Andreas.
I wanted to ask whether there's any experience or any experiments with using AI to identify potential scientific fraud, because making up data and manufacturing plots of non-existing data, things like that, might leave traces that could potentially be identified with AI tools. So are you experimenting with this?
I personally am not, but I know with tools like the one I mentioned, Snapshot, they look for image manipulation as well. And so you're right, they will leave traces, but the question is, it's almost like an arms race where, you know, you detect something and then yeah. So I think at the moment, scientific fraud has always been quite difficult to detect. And so if we can detect it in a kind of standardized and regular way, that would be great. But I'm not aware of anything specific for looking at fraud, whereas, you know, they can just look at whether an image has been manipulated and then go from there. But then a human has to walk in, I think.
Yeah, Giacomo.
Hey, Mike, thank you very much again. I just wanted to say that a question I had. You said that tasks requiring accountability can only be performed by human. There was you mentioned that. So can you be more precise? So can you make an example? So just to understand better what you had in mind in the context of editorial.
Oh, yes, of course. So in our papers, when we publish them, we have what we call an author contribution statement. So here, this is where you say, Giacomo came up with the idea, and then this person did this part of the experiment. All the authors contributed in the writing, and, you know, maybe somebody came in with a model. So the ideal statement will have that, although quite often, and we push back, we see people say all authors contributed equally. So if there was some kind of, say, AI chatbot involved, then how would they take accountability? You know, how would you? It's very difficult to say, well, you know, this AI tool did this. It's very yeah, I just don't think it would be accountable, if you see what I mean. You could go back and query it maybe, but will it come up with the same answer all the time?
Yeah. Okay, I see. Okay, thank you.
Thank you. So May, will you be able to stay until the discussion at the end?
Yes.
Okay, that's perfect. That's great. And then I will keep some of my questions then for then, because then we are right on schedule, which is great. And we can then move to our next speaker. So this is Claudio Urbina, who is a master student from the University of Chile in Santiago. And Claudio will talk about applying large language model to track ESO data used in the literature. So Claudio, you have 15 minutes for your talk. Please go ahead.
Hello, everyone. Can you hear me well?
Yeah, perfect. Thank you.
Great. So, is my screen sharing correctly?
It's great. Perfect. Yeah.
Yeah, right. So, well, my name is Claudio Urbina. I'm a student from University of Chile, and I'm going to talk about how we are applying large language models to track ESO data used in the literature. So, let's start with some context. So, ESO has been tracking the use of observational data in the literature for decades. And if you look at the graph right here, you will notice a clear trend. So the use of ESO data in publication has been steadily increasing over time. In fact, Compared to 1996, the amount of data used has tripled today. So now you might be wondering, why is this so important? And well, just like any organization, ESO needs to measure the productivity and the impact of the instrument and telescope it has been built over the years. So this information is crucial for making informed decisions about future investment, upgrades, strategies to maximize the impact, etc. So let's talk about how the ESO has been tracking the data usage in the literature all these years. So they have a semi-automatic process, with a few steps. So first, every week, ESO gathers all the newly papers that have been published from a selected astronomy journals from the ADS database. And from them, there is a search that is performed to search for a specific list of ESO-related keywords, and they filter all the papers that contain 2 or more of these keywords. From them, and here's where the manual part comes in, the ESO librarians review the papers that contain these keywords, and they read through the text to understand the context in which the keywords were used, to verify whether they refer to the use of observational data or not. And in addition, they have to cross-check this information with the ESO archival records. So finally, once this whole process is complete, papers confirmed that have been used or not ESO data are tagged and stored in the TailBib database. So, and they are tagged as TailBib papers or non-TailBib papers. So let's dive into the criteria that they use to decide whether a paper is included or excluded. So basically, a paper is included if they use partially or exclusively ESO data, whether it's proprietary or archival. On the other hand, excluded papers are those that quote results from literature, mention ongoing projects, suggest future observations, describe instrumentations, develop models or run simulations, or use images solely as visual reference. So, as you can see, this criteria is quite nuanced. So simply finding the ESO-related keywords in a paper is not enough. You need to carefully read the paper to understand if this ESO data was actually used. And in addition, for the ESO, it's crucial to not only confirm the data used, they also need to identify which instrument or telescope provided that data. So as an example, in the crucial, the above paper is an included paper that has a clear and explicit paragraph demonstrating the use of ESO data, while an excluded paper only mentions ESO-related keywords. For this project, we work with a subset of the TailBib dataset, so specifically focusing on papers from 2014 to 2023. From a total of 2,302 papers on those dates, 1,241 papers were labeled as TailBib papers, meaning that they use ESO data, while the remaining papers were categorized as non-TailBib papers. It's almost a 50-50 portion of sets. So let's take a look to the real examples of how papers are stored in a TailBib dataset. And for each paper, we capture metadata like ADS URL, journals, publication years, etc. But the most important fields are bib code, status, data, and comments. And as expected, TailBib papers tend to have much more detailed entries compared to non-TailBib papers, because, of course, the data field is populated with all the detailed information about the telescope, instrument, ESO programs, where the data was used, etc. And of course, non-TailBib papers doesn't have that information. So before using LLMs, a baseline approach was explored early this year, and this we were calling baseline for comparison. And this exploration works like this. So first, like always, we started by identifying all the ISO-related keywords in a paper. From them, we extract and concatenate all the surrounding sentences around a keyword, and we join them in one single large block of text. So in the example, the red sentences are the sentences that have an ISO keyword within them, and the black sentences are the surrounding sentences to add context to the text. So from them, we use AstroBERT, a version of BERT fine-tuned with astrophysical text, to embed this block into a vector representation, to finally use the same model to classify them as a TLB paper on a non-TLB paper. So this baseline approach used AstroBERT, and AstroBERT was retrained as a sequence classifier using a training dataset of 362 papers and tested with a dataset of 98 papers. So the results were quite promising. It has an accuracy of 0.77 and a F1 score of 0.78, indicating a very good balance between false negative and false positives. And actually, this approach is relatively simple because we took all the sentences that might relate to the use of ISO data and classify the entire paper based on that. And one of the strengths of this approach is the lightweight nature, because AstroBERT is a very, very efficient model that can even run on a laptop. So, however, this approach had a key limitation, and it's the lack of explainability. As we discussed earlier, it's not just important to determine whether a paper uses ISO data or not. We also need to know which instrument or telescope were used, and this approach didn't provide that level of detail. So we revisit the core problem, and after multiple discussions with ESO librarians to better understand their needs, we realized that the criteria using for excluding or excluding was not mutually exclusive. For instance, a paper might be excluded because it focuses on simulations, but that doesn't necessarily mean that the author didn't use ISO data. In fact, they might have used ISO data to run all the simulations. So both conditions can be true simultaneously. And with this in mind, we propose a new approach to understand what qualifies as TLB paper. And essentially, we break the criteria into two key questions. First, what kind of data was used in the paper? It could be observational or non-observational data. And what is the purpose of the paper? And can be astrophysical discovery or non-discovery. So this category are mutually exclusive. And the combination of the answer of these questions will determine whether a paper should be classified as a TLB paper or not. So we divide, as I said before, the problem into two tasks: identify the kind of data and determine the main purpose of the paper. So here's a table showing the possible combination of the answer to these questions. And as you can see, only the paper that use observational data from an ISO telescope or instrument, and the purpose of the paper is making a new astrophysical discovery, qualify as a TLB paper. Any other combination results in a non-TLB paper. And the next slides are focusing on presenting the proposed solution for the first tag to identify the type of data used in papers. So let's walk through the proposed workflow, the new proposed workflow. So first, just like before, we start finding all the ISO-related keywords in a paper. And for each instrument, we extract and concatenate all the sentences that contain that instrument. So we are not concatenate all the instrument in one big text. So we have now multiple texts, and we contextualize each text by appending the name of the telescope or the instrument that is being analyzed at the end of the text. So with this, we are more clear in which specific ISO data is being discussed. Finally, we are using Llama 3.1, 8 billions to classify the contextualized sentences as either observational or non-observational data. So In order to implement this new approach, we first needed to create a new dataset. And here's how we did it. So first, we downloaded all the LaTeX source code from nearly all the papers in the TLVIP dataset. Then, using a custom code, we converted all the LaTeX files into a Markdown format, cleaning all the text and removing unnecessary elements like reference, citations, equation, etc. And from them, we use the TLVIP dataset to extract and concatenate all the sentences mentioning ESO instrument or telescope. And we labeling them as observational or non-observational. So with this in mind, we expand our dataset to observational and non-observational, and from 23,000 papers, we got more than 40,000 labeled instruments and telescopes. So here is a bar chart that shows the top 10 instrument or telescope by the number of samples that we have labeled. And for each instrument or telescope, we have both categories, observational and non-observations. So we finally, for each paper, we identify an average of 2 labeled instrument or telescope. Finally, we fine-tune Llama 3.1 as a sequence classifier using a training set of around 10,000 labeled instruments. And for the testing the model, we use a dataset of 300 papers split evenly between TLVIP and non-TLVIP papers. So the model actually classified 128 non-TLVIP papers correctly and 129 TLVIP papers correctly, with a few misclassifications as seen in the matrix. But actually, our proposed model improved accuracy, not very much, but improved accuracy and the metrics to 0.81 in all the categories, to precision, accuracy, recall, F1 score, etc. So this approach not only offers improved performance, but, and this is the most important thing, it provides a greater explainability, because we now can identify the type of use, the type of data used from a specific instrument in a paper. The main downside is the increase of computational demand, because we are using Llama right now and not AstroBERT, and Llama, of course, need more resources. So let me show an example about how this works. So we have a paper, for example, the Triplanetary Companions around M67 stars, and we found 3 keywords, Euler, HARPS, and Swiss. And for each keywords, we find the sentences. So for Euler, we have 2 sentences, for HARPS, we have 7, and for Swiss, we have 2 sentences. So if we contextualize these sentences, appending the name of the instrument or the keyword in this case, and we pass it to the trained model, we are going to have, like, for example, for Euler, we have that both sentences were classified as non-observational data. And for example, for HARPS, we have 6 sentences that were classified as non-observational, but 1 was actually classified as observational data. And for Swiss, same case as Euler. So as we have at least one case, one positive case, the whole paper is going to be classified as a TLVIP paper, because the paper used ESO data. The thing, of course, is that we are missing right now the second task, that it is check the purpose of the paper. And how contextualized sentences work and why are they so important? So basically, we have, for example, here a sentence that can have multiple keywords. For example, US and giraffe. So if we ask for to the model for this sentence, but contextualize them for US or giraffe, we're going to have even different answers. For US, we have a positive case, but for giraffe, we have a negative case, because actually this text tells you that we are using observations of US and not for giraffe. And we can check other cases. For example, what happened if we replace the US words in the text for any random word like ABC or whatever you want, and we ask for the model again, but about US. Now the model is telling you that no observation were used from US, And that is right, because the text, it doesn't have US anymore. And if we ask about ABC, the model detects the new word, and it tells you that that is a positive case because we are using observation of ABC in this context. And this give you the flexibility to have new instrument or new telescope or ask for new keywords that weren't in the initial set without training again the model. So that is very great. So finally, we propose a method to classify all these papers as TELVIP or non-TELVIP papers by detecting the use of observation and keeping track the instrument and the telescope, and it's great. And the early results of this approach have better performance than the baseline, but we need to apply more statistical measures to be sure about how is the model performing. And what is the ongoing work right now? Basically, we need to continue studying the classification of the paper purpose using the abstracts of the papers, improve the method to reduce key mistake. And in this case, what is really important to ESO is false positives, and also implement the simplest models that can do this job. I mean, we are using Llama 3.1, but maybe there is a smaller model that can do the same job and being much lighter than Llama. So actually, we have to retrain the model with the full data set. I told you before that we got over 40K of labeled instrument and telescope, but the Llama model used was only trained with 10,000. So less than the half of the data set. So we need to train the full model with the full data set to see how far we can get. So that's all. Thank you very much.
Thank you, Claudio. This is likely a useful application of large language models to help librarians and astronomers. Are there any questions for Claudio? I mean, I will start with one, and it is that, of course, I guess that for the librarians, what is very important is the completeness. I mean, they want to have all the papers that have been published and using ESO data. And of course, they want to be accurate. You don't want to have wrong papers coming there. So for now, you said you reach an accuracy of about 81%. So is there really a hope that you can reach 100%? Or does it mean there will always be the need for the librarian to go themselves and check everything?
Yeah, we can have like different stages, because first, the model is trained to check the use of ESO data as observation or non-observation, and not actually like classify a paper. So we have to do that step to the final decision about if a paper is or not a TELVIP paper. It's not doing by the model. It's doing like by the conclusion about the result of the models. But so, for example, the model have a better performance classifying observation and non-observation, and we took that to classify the paper as TELVIP paper or non-TELVIP paper. But the model actually is not classifying the paper as TELVIP paper or not. So the metrics are like different, and we actually have better performance, like 90% classifying the data as observation and non-observation. Is different to the metric of the TELVIP decision. But I think we can have even better performance using the whole dataset, because there were a lot of cases that were not included in this first iteration. The 10,000 cases that we trained the model. But I think we can have like different threshold to, for example, we can say that the model classify the use of ESO data of an instrument with a confidence. For example, like maybe the model is not very sure about the use of ESO data for a specific instrument. Yeah, and we can check those cases. And when the model is very sure about 90% or lower 10% because they didn't use ISO data, we can just like bypass those cases and check only like 55% or 45%, those that the model is not very sure.
Okay, perfect. So there is a question on the chat about how a scientific paper can fall in the non-discovery category.
Yeah, there are a lot of, for example, papers that are like instrumentations papers, and they just compare like technical specification because between instrument and telescope, and they don't add like new scientific astrophysical discoveries. It's just a comparison between instrument or papers that, and these are criteria for ISO. For example, that models or simulation that do prediction about future, but they are not actually putting over the table a new discovery because they are prediction. We don't know if they are going to happen or not. Those are not discovery, astrophysical discovery. So those cases are going to non-discovery purpose.
Okay, thank you very much. So we have to move on. So the next contributed talk is by Simone Astarita from ESAC in Spain, and he will talk about delving into the realm of ChatGPT. Is the language of astronomy changing?
Thank you. Can you hear me well?
Yeah, perfect.
Okay. Hi. So I work at the European Space Astronomy Center near Madrid, Spain. My main work has been actually on the engineering side. So I work on NLP applications, but I have a more theoretical background. And during my time here, it has been quite clear that there was an interest in analyzing how and what was our NLP models were using by astronomers and exactly what was going on with this. So all the way back in May, we started doing an analysis of the problem. And we actually even question, is this even a problem? Is anything even happening with the language? So I'll go down exactly on sort of the story because it's a very recent story. This idea of checking whether or not certain papers have certain words or whether the frequency of certain words has changed. It's very much a 2024 story. So I don't think I have to convince any of you the science and ChatGPT mixed together from the get-go. So there were plenty of papers that talk about how to use ChatGPT, what effect it might have, how it can impact different subfields of science. However, there was actually very few papers that looked at how much ChatGPT influenced the papers that we are writing. So there are, if you look at what I call early 2024, so January to March, there are like a few papers on the topic, but they tend to focus on few computer science documents. There's no mention of the word delve, which I actually think by now many people that are interested in the topic have heard of it. And there's nobody who's like compiling list of words and checking their frequency. There's only one preprint that look at things like that way, and it was actually written by a librarian who had no intention of publicizing it or having an academic career. So basically between January and March, the topic was talked about, but there was not much research on it. Then Nguyen, which is a very famous voice in the AI world, published this tweet, and I think this tweet may have actually caused all the discussion we've seen today about words like delve. So basically, it said, do we think that medical studies has been written by ChatGPT? And then simply going to PubMed, you can search for a word, and we observed this, that in 2023 and 2024, there's a skyrocketing of the use of the word delve. And this is, and then Nguyen says in a very matter-of-factual word, we all know ChatGPT overuses the word delve. And this kickstarted truly almost like a movement in terms of like analyzing whether or not this was an issue. I even have like a similar tweet for space science. So if you look for if you go just on NASA and you search for the word delve, you do actually see similar results. You can look it up and see that, yeah, you see this massive increase in 2023 and 2024. But these graphs don't tell the whole story, right? Because this is not adjusted for the number of papers published, for instance. And also people were a little skeptical because in both cases, you can see that it seems to be there seems to be an increase even before 2023. And how exactly do you explain that? So that's where sort of there was an explosion of papers on the topic. The situation changed a lot. A lot of these papers were actually about PubMed articles because the original tweet mentioned PubMed articles. There was a lot of focus on specific words, and there's been like a whole variety of techniques that have been used to try and solve this issue. So for instance, they mentioned frequency analysis. This is the same paper May mentioned. A lot of what I called word search, which is sort of what we did, where you try to identify specific AI favored words and then check whether or not they've increased in usage. And then, entire models meant to detect ChatGPT, although that area, no matter how promising, is still quite debated, I think. I think to me, the most shocking result was that it's such a hot topic that we published this preprint. This was all the way back in May, because that was then accepted to a conference, the SPICE conference up in the UK, which was a conference about the use of AI in space science. And before even the conference happened, we already had the citation of another paper that tried to do a similar thing, but instead of doing it in astronomy, they do it in condensed matter physics. So it was just already like, clearly everybody's like talking about it, and everybody's trying to figure out how to test this issue. This is how we decided to go about it. The idea here is that we wanted to do something that is a little bit statistically accurate. We're using AI. These models are extremely complicated. There's a ton of statistics, but then when we try and estimate how we were using them, we're using actually rather simple methods, but we should still, be sure that the statistic behind it are sound. So what we did is that we tried to identify relevant AI favored words, and to do this, we did it through a ChatGPT human corpus. Later I'll explain exactly what we did for that. And then we looked at astronomy papers that were not part of the corpus, and used those astronomy papers to estimate whether there was an increase in the occurrence of AI favored words. And then we checked whether or not the increase was statistically significant. What we did not, this is not really the purpose of this presentation, is estimate the percentage of papers that use ChatGPT for a couple of different reasons. The first reason that, as someone who has a bit of a background in quantitative linguistics, I actually don't know that the methods that I've seen being used around to do this sort of estimation are completely sound. And the second reason is that that was really not what we were interested in. The entire point of the study to me was to find out whether or not there is a change in the language that you're using. Like, are these technologies powerful enough to shape how we were describing the science that we're doing? Okay, so now I'm gonna delve into the results. I'll start by saying something. I think if you don't get the vibe, this is sort of what you think this presentation is going to be. You're going to see a timeline, you're going to see a frequency, you're going to see ChatGPT being brought up, and you're going to see words like delve skyrocketing. This is exactly what's going to happen. But again, I think it's important to explain the methodology because this is such a hot topic. Everybody's trying to publish a lot on this topic very, very quickly. And I do think that when we discuss issues related to AI, we really need to be careful on being sure that the research and the opinions that we're forming are based on actual facts. In a sense, I don't think I'm doing this presentation to convince you that something like this is happening. I think most of you are probably already convinced that it's happening. I'm rather doing this presentation to highlight the importance of actually proving that our suspicions are correct. So I'll start actually by explaining a concept that I don't think it's very much explained, but there is two ways to talk about frequency when we talk about the frequency of words. So you may hear people saying the frequency of the word delve has increased. What does that mean? There's two ways of interpreting that. One is what's called frequency per token. The idea here is that you count the number of words in your corpus. That is, a corpus is just like a data set of documents containing words. And you can think of this example in this slide as like a small corpus. There are 28 words in that corpus. So you count the number of words, and then you count the number of times the word you're looking at is occurring, and and then the number divided by 28 is the frequency. This is sort of, I think, the more intuitive version. But that is not what you get, absolutely not what you get when you look at, for instance, when you type the word delve in NASDS or in PubMed or any other search engines. What you get in that case is an approximation of frequency of occurrence. Frequency of occurrence is how many times the word appears at all in the documents in your corpus. So if you think about these 4 sentences that I have here as the 4 different documents in my corpus, then I just count the number of documents that contain the word at least once, and then I divide it by the total number of documents in my corpus. These are two concepts that are somewhat related, of course, but not very strongly. So there's nothing like a statistical correlation between them, for instance, because they're really measuring different things. And very often you have to be sort of careful when you read the paper about this topic, because people will just use the word frequency, but it might mean either of those, and it's very careful to you have to be sort of careful in understanding what they're actually talking about. So okay, now let's do the first step. I talked about they use a corpus to identify what words ChatGPT prefers. This is actually very important, at least to me. If I just type the word delve and I see this massive spike, and I decide that the word delve is a word that ChatGPT prefers without any proof, and specifically without any proof that is independent of what I see in 23 and 24, I just fall in a circular argument. I'm just saying, hey, these words have increased in 23 and 24. It must be because they are produced by ChatGPT. So I'm not really proving that ChatGPT is influence. I'm just assuming that ChatGPT has been the cause of this influence, and then I'm just sort of going in a circle. So for us, it was really, really important to actually find a somewhat independent way of estimating what ChatGPT prefers. The way we did this is that we took a corpus that already existed by a team of Princeton scientists that use human text and ChatGPT written text. So the way they did this is that they took some articles from a variety of disciplines, and then they rewrote chunks of those articles using ChatGPT. And the articles that we selected were all before the year 2023 to avoid any interaction with articles that happened after the publishing or the public access of ChatGPT. This way, when we actually calculate the frequency per token, so we did sort of this calculation that I was talking about here. We did, of course, through Python, we calculate how common certain words were. We were sure that when we were comparing human text with ChatGPT written text, there was nothing that could have been influenced by any other thing going on in 2023 and 2024, because we did not consider articles of that time period. And actually, this dataset doesn't actually have anything to do with astronomy specifically. It has to do with physics, mathematics, computer science. We did not look at astronomy specifically because we sort of wanted to be completely independent. And we extracted the frequencies for each word, and we compared, for instance, the absolute difference in frequencies you can see in this graph, and we found out certain words are preferred over others. However, this is just the difference in absolute frequency, no relativity. When you want to check what words ChatGPT overly prefers when compared to humans, you have to check for relative frequency. So, for instance, there's a lot of math that goes behind this, but basically we did this relative frequency check, and we extracted the top 100 most AI favored words. Now, maybe I'm biased because I was the main author in this paper, but I do think this is a big deal, because now when we extract these words and we extract words like delve, underscore, intricacies, realm, we're doing this completely independently of the increase in set words in 2023 and 2024. But we are completely avoiding this circularity. We are not saying we saw these words increase, they must be from ChatGPT. We extracted these words just by using this different corpus, and now we can go back and check if these specific words have increased. And I do think that's very important, because it actually gives us a non-circle, statistically sound view of the problem. How did we check it? We use actually NASA ADS. We use the API. You can check the results just by going to NASA ADS if you actually use exactly the parameters that we use. So it's completely checkable. But also, this code is public, and you can use the API as well if you're familiar with the API or with Python. NASA ADS basically it's sort of calculating frequency of occurrence. It's not perfect. Like if you search the word "we" on NASA ADS, it doesn't return anything because NASA ADS filters specific words. But that didn't really impact our results, because none of the words that are filtered by NASA ADS are the words that ChatGPT preferred. So we use NASA ADS to check, okay, do the number of documents where these words show up increase in 2023 and 2024? And we see that. We absolutely see that this is happening. So these are the top 10 words, for instance, and if you look at the y-axis, that's the frequency of occurrence in absolute terms. So you can, 0.06 just means 6% of the articles in 2024 have, in this case, the word intricacies, compared to approximately 2% of the articles in 2022. So we see, in fact, massive increase for these specific words. Again, this is the top 10, but we check for the top 100 words. However, there's still a little bit of a suspicion of what's happening, because it does look like they are increasing even before the year 2023. That's why we did a more sound check. So is this statistically significant? And to do this, we actually check with a control group. What we wanted to do is, check with that the AI words behavior should not be different from the behavior of a control group in years before 2023, and then the behavior should be different in 2023 and 2024. This is the second graph where we basically this control. Instead of doing individual words, it's a little more general. So you can see the top 5 words, the top 10 words, and so forth. And then in brown, the control group. If you see it, the control group actually behaves very similarly to other words before 2023. And then when 2023 happens, there is like a massive difference and a massive skyrocketing. This is, again, something that I care about. This is an actual statistical analysis that proves that this increase that we see just visually is actually statistically relevant. We can go ahead. We could talk later if this is something interesting. Why does it look like these words are still increasing? And it's mostly at least in our analysis, it's mostly to do with the fact that papers just in general tend to be a little longer, just on average, or in particular years actually. More specifically, it's the kind of documents that, for instance, in SSDS indexes, they're more different. So for instance, if you look at the year 2000, there's a lot of articles, but not many book chapters or things like that are longer. And in longer documents, the frequency of occurrence tends to be higher, just because people use more, a larger variety of words. But yeah, so we extracted these words. We checked that there was indeed a frequency increase in 2023 and 2024, and we checked that this increase was statistically relevant when checked against the control group. So what now? Now we are trying to create a specifically astronomy versus ChatGPT, a human versus ChatGPT astronomy corpus. The idea here is that, to be completely sound, we should try and check this specifically for astronomy. So we are using some credits that we got from Azure Microsoft to run ChatGPT on a bunch of astronomy abstracts and rewrite them. Again, I can go more into depth in how we're doing this, but we're trying to create this public corpus that's going to be utilized by anyone who wants to utilize it, and it's just going to be very easily downloadable. And we want to repeat a similar analysis and even more complex linguistic analysis using this new corpus to check that indeed this event that we really think it's happening is truly happening. And we want to check even more complex linguistic phenomena and see if ChatGPT, for instance, is changing not just the frequency of a specific word, but how, for instance, frequency is distributed. There are a lot of quantitative linguistic studies on how just in general human language distributes this word. We can check if ChatGPT is changing the distribution, right? We are trying to keep it up as well as we can. The GitHub repository. So if you're interested in the code, you will see that there are very recent changes, because we are this is again, the publication of this paper is very recent, and so is the code. So we're trying to keep up to date, because there's a lot of work that we're doing in this topic right now. But so maybe you sometimes get to the GitHub repository, it doesn't look perfect. You can let me know. But yeah, we're trying to make the code very easily available, because I think reproducibility is kind of a huge deal in AI in general, and at least this sort of thing that doesn't require GPU or anything like that, we want to make sure people can actually do it. And then if you're interested in sort of the longer version of this talk, you can read the archive paper. There is actually a paper coming in the proceeding of the conference they presented some of these results in, and they're just not, the proceedings are not published yet, but there is actually, a peer-reviewed paper you can also cite in case you want to refer to these results. I hope this was interesting to you. This was a very interesting project for me, and I really liked studying it. I don't come from an astronomy background. I'm a quantitative linguist, then became sort of a AI engineer. And so going back to my old roots to do this was extremely exciting for me. I do think that, I don't have, I guess, as much maybe of a strong opinion on the ethics and the legalities of using LLMs, but I do think that there is a certain importance in making sure that when we consider what these LLMs are doing, that our beliefs are based on an actual fact. Because we have the tools to do the checking. I think we should do it. Thank you.
Thank you very much, Simone. So that's really very interesting. I guess it would be also interesting to do the same, to see if we see the same effect in the codes that have been written and used, but I suppose this is more difficult. So I'm waiting if there are any questions for you. In the meantime, I have a curiosity. I'm not sure you mentioned it or not, but really, I'm surprised. I mean, why does ChatGPT use so much the word delve? Because it's using the internet in principle. So why the insights are, no, I'm going to use this one more than others.
Yeah. It is quite finding out why it is actually quite hard, because it has to do with the training process, right? And ChatGPT training process, it's OpenAI is not very open about its training process, so it's sometimes hard to check. I am working on trying to actually do it to find out why in a sort of similarly statistically sound way. Basically, what I heard as the leading theory is that when it comes to specific tests like academic tests, one of the ways that ChatGPT is improved from sort of the baseline is by having human annotators tell it what it's doing wrong and what it's doing right. So the idea is that before ChatGPT got released to the public, certain questions and certain answers are checked by humans and maybe corrected by humans, and ChatGPT is then fine-tuned on those corrections. Now, where would you go and find these human annotators? You would go and find them in the cheapest English-speaking country, which is Nigeria. And one of the leading theories is that certain words like delve are used more often in Nigerian English when it comes to academic text. So what I'm trying to do, but this is sort of like we're really at the beginning of this project, is trying to compile a data set of Nigerian English for academic purposes. So like high school essays, papers written by Nigerian authors, and so forth. They come before 2023. Anything after 2023 could be impacted, so you cannot use that. But before 2023, and check if perhaps that's why. Perhaps we're just looking at a specific version of English. That's actually, again, very commonly known in linguistics. People from different countries speak English tend to prefer different words. That's perfectly normal. But perhaps because OpenAI uses cheap annotation from those countries, then we see this effect and this preference for words. But again, this is, I think several people believe this, but there's not a study that has checked this for sure. We're trying to do it, but it's harder than it sounds.
Yeah, but this is indeed a possibility, because I was indeed, once I discussed about this problem in a talk, in a conference, I was approached by somebody who said, but now in our country, we typically use this word. And now you are telling that if you see this word in a paper, it must have been written by ChatGPT. So what should we do? So it can be a problem for that. But I guess also we have to be careful, because the way that people learn how to write papers, learn in quotes, is by simply replicating what exists. And of course, often they will try to use words which sound a little bit more smart, because they give the impression, okay, it makes my paper more smart. And that's why maybe this is also why this kind of words just gets replicated, even so the people did not necessarily use ChatGPT, but they may simply copy other people who have been using that as well. So that's also, of course, one of the complications in this process.
Yeah, that's also why it's really hard to build a tool that checks whether or not something's ChatGPT written, because especially for non-native speakers, it is quite common to read very recent papers and replicate the language when it comes to writing the science that you have done. And so maybe when we see this massive increase, it might be sort of like a self-fulfilling prophecy, where some people use ChatGPT, and then young scientists, especially, or early career scientists who maybe don't speak English as a first language, or they're not as confident, just replicate the language they see. And if they see certain words popping up everywhere, they're just like, well, I must use those words in order for my science to sound professional and correct, right? So it's a really challenging problem.
Okay, thank you very much. So we have to move on, I'm afraid. So our last speaker before the break is Miguel Aragon from the Universidad Nacional Autónoma de Mexico. And Miguel will discuss Science 2.0 with artificial intelligence, quite a program. So please, Miguel.
Hi, Henry. Can you hear me well?
Yeah.
Okay, I will share. Oh, wait. Had to give some permissions, I think. 1 second. Okay.
Yeah,
Can
it
you?
might be that you need to restart then.
Oh, okay. I'm sorry.
Don't worry, we will for you. We will.
Okay, 1 second.
Yeah, yeah, that's typically happening.
So we were supposed to have a long break, so it's okay. There is no hurry.
Exactly. No, the important is that here, as I make co-host immediately again. Yes. Welcome
Okay,
back.
I'll try to share. Yeah, thank you. So can you hear me well?
Yes.
Okay, let me just make space. Oh, hi, everybody. First, I would like to thank the organizers for this wonderful meeting and for giving me the opportunity to share some of my experiences, and also to the speakers. It has been really nice to hear you all. Sometimes I had to wait until the morning to look at the recordings, but it has been really, really nice. A lot of interesting things. So I just want to share some of the experience that I had with artificial intelligence and what I think, at least for in my case, is a new way of doing science. This has changed the way I operate normally, and it's something that I want to do also with my students later. So this is how I used to program in the year one BC. Of course, BC stands for before ChatGPT. So we just sat and think very hard, how to solve a problem. We went to Stack Overflow and try to solve some programming problems. Now we had ChatGPT to do that for us, although with some problems. No, this is how we used to write the papers. I still struggle a lot as a non-English speaker writing papers and the introduction. Sometimes I cannot find the right word. Sometimes a sentence doesn't fit well. It takes a lot of time to get these things done. Tech support also, what I call tech support. I realized that I spend a lot of time with my students teaching them the tools that I have developed or my group has developed. These are very specific things that we don't have manuals for them, so we had to spend a lot of time on the computer with them, teaching them how to use the codes. So then I thought, maybe being a bit lazy, I thought, okay, maybe we can have like a virtual clone, a digital clone that is going to be like a code assistant that understands my codes, because I realized that most of my code is a repetition of code that I wrote before. We use some simulations. We know how to extract some data from those simulations, and we just need different kind of data or handle the data in a different way, but they are basically the same codes or the same base. Technical know-how, also we have our tools. We always use the same tools that we develop. We have to tell people how to use them. This is something that I don't have to do this all the time with my students. And writing, I would like to have an assistant who also knows me, not just a general ChatGPT model, a general LLM model, but something that knows how I write and my style, the things that I have read, that I have written. So I'm going to share first some experience with the agents. This is something that I did with the student, Fernando Esquivias. He's an undergrad student. And what is an agent? We already saw it, but it's an LLM that can write, execute code, access internet, your local computer, etc. Now we open the world for this model. So we have an agent that has access to, we develop an agent that has access to Wikipedia, NASA, archive, search engine, can write Python scripts and execute them on their computer. So something that I find really amazing is that now the hottest programming language seems to be English. We program these agents with just plain language. We tell it these are all the actions that you can do. We gave it we give some general guidelines how to operate, and that's all. The rest is just infrastructure for the agent to work. So we run we have been playing this all work in development. So we ask our questions to the agent. So giving the coordinates and recipe for the Fornax closer. So it says, okay, I'm going to Wikipedia. It makes a query, and then gives an observation. The Fornax cluster is a cluster of galaxies at a distance 90 megaparsec, but it doesn't get the coordinates. So I didn't give the complete answer. So it's going to try NASA ADS using some key terms. It looks for Fornax cluster, coordinates, and redshift. It doesn't, NASA ADS doesn't return anything. So okay, it's going to try again with NASA with different keys. It's going to look for Fornax cluster. Now with Fornax cluster, it gets a lot of papers, a lot of abstracts. So it checks them, and then it gives me the answer. So this is so cool because what I would like to have is a system that gives me information without me having to train a student, do it myself, go online, just give me all the galaxies that are in this range of redshift. I want images observed with Hubble, something that I haven't already shown in this conference. We can also interact with our file, which I find also amazing. So I tell it, okay, read this file and show me its contents. So it writes a little Python script and shows me the content on the file. That's very simple. I can ask something more difficult, like, okay, make a scatter plot, photometric redshift versus spectroscopic redshift, and save it in some image. So it writes a Python script. This is the Python script that it writes, goes to my folder, reads the data, and makes the plot. This is so, I don't know, for me as an astronomer, this is an amazing tool because it allows me to explore data in a much faster way than before. Because I can just go to but this is all running on a Python Jupyter, but we want to have it on a prompt, like a little server, and just ask data, explore our data in a much faster way. Now, how do we enforce compliance by the agent? Because the agent, sometimes they just go crazy and do crazy stuff. So this is something that this is an example from the project Open Interpreter. These are some instructions. What I found very interesting looking at the instructions is that at the end of this little file, there is this instruction. You must follow these 4 instructions exactly, and I will tip you $200. So that is kind of crazy. So some people actually look into that. If you tell an LLM that you are going to give it a tip, it works better. So this is the size of the answer with respect to the baseline. If you don't tip, you give $20 or you give $200. You can also tell it that you're going to get tickets to a Taylor Swift concert. You're going to achieve world peace, make your mother very proud, etc. Somebody even wrote a paper with some guidelines how to get good answers from LLM models. All this is to say that we don't really understand how these things work. And at this point, I think we are all kind of hacking, or at least I am just hacking with these tools. We are far still from making the tools do what we want in a very objective way. So one way that we have been discussing, or people have been discussing in this conference, and that I'm using a lot, is retrieval and augmented generation. And the idea is very simple. We do this a lot in astronomy. So we have some data, in this case, image of galaxies. We pass it through a neural network, and at some point we extract some embedding. And this embedding is a projection of our data into some space, into this latent space. And in this latent space, we can group objects by similar properties. The problem is that we don't know what these properties are. No? That is one problem of latent space. Well, we can do the same with text. So we pass text to a model, and we get a vector. We are using OpenAI service for this. And then we can create a body of knowledge, and then we can make a question. This question gets embedded also, and we find the similar region, the points closer to my question, and we hope that the answer will be somewhere there. So we are using RAG or LLMs as interfaces to code. So sometimes I'm writing code, and I know that I wrote a function 10 years ago, and I cannot remember this function, or I wrote some code 10 years ago, and I cannot remember the code. I can do a search by words. That usually doesn't work because there is so much code. But LLM allows me to do smarter queries, semantic queries. So this is just one screen of some of the functions that I have developed over the years. I have hundreds of them, and probably all of us have hundreds of functions that we have developed. So one thing that I did is I just encode all my libraries, in particular the docstrings of all my libraries, created this body of knowledge. I did docstrings with a language model also. So this is how I used to have my functions. So I pass it through a language model, asking the model to create docstrings with the right format. So now everything is homogeneous in my code of my base code. So I can ask questions. like write a Python script to read a floating point data cube from a file. And this is I have developed a very specific, well, I have a custom format for my data files. So it goes into my code and writes the answer. So this answer is very similar to the code that I wrote, or to the original code. So I can add something more, a bit more complicated. So go to the TNG. Well, I have some data from TNG, get the subhalos, the most massive subhalos. Then from these subhalos, extract positions, mass, and temperature. You have to compute the temperature because you don't get it from the simulation. So this is the code that it writes, which is a very similar code to the code that I used originally. If I add the same to a system like Perplexity, it gives me also a code that I can run, but the temperature is not computed correctly. Because we are using a very particular simulation with very particular units, and this is how we should compute the temperature, not how the ChatGPT thinks that should be computed. So by using my own code, I guarantee that my code will be functional, and it will use all my data formats and all the functions that I use. Now, as a non-English speaker, for me, writing it has been always difficult. But in general, in all fields, there is this idea of ghostwriter. No, we often see people writing papers, writing books with a ghostwriter. The idea is this person, you talk to this person, no, and they help you to write the paper. You get ideas, but the ghostwriter helps you put them in paper. So I'm developing this. It already works, but it's still work in progress. A little system. I'm using Google Docs. So we are writing a paper in Google Docs. Then there is an agent that is constantly checking the paper, and when it finds some keyword that I introduce, it takes the text in that keyword after that keyword and does some RAG to give me suggestions, write references. Sometimes I ask it to help me. I'm stuck with some words. I cannot find the right word. I cannot find the right way of saying something. And then it does it for me. The difference between this and using ChatGPT is that it does it reading my papers. It has a base knowledge with all my papers, and I also include all my emails. So it has my own style. It knows the papers that I have written. It knows the papers that I have cited. So it sounds more like me. This is the prompt. You're just a helpful assistant. And I just tell it that he's going to use some preamble. I'm going to give it some extra information to answer the question. And I can give it some hints. So for instance, I'm writing here. I don't have it live because sometimes it fails. Most of the time it doesn't fail. So I have I'm writing a paper here. I want to say something about the eigenvalues of density field for finding cosmological walls. So I write a keyword LLM, and then I open and close this parenthesis. So it knows that everything inside is an instruction. I give it some hints. I give it a hint. Use the MMF paper. It's a paper that I wrote about this technique. I tell it how many points it should use for the RAG. I wanted to use the 10 closest points, and I also want to use some context. It's going to look into my body of knowledge for sentences that sound like this one, but I also want to have some context before that. So I tell it to use 5 chunks of data of text before and after that. So just as a comparison, this is what would happen if I ask the same to Perplexity. Perplexity goes in, I ask it to give me a paragraph into eigenvalues and density of walls, and it tells me that the eigenvalues of density field in good walls, so it has nothing to do with the answer. Sometimes it gives a good answer, but not the right answer in general. So this is what the ghostwriter tells me. Density field walls, eigenvalues are crucial for molecular characterization, etc. So this is something that I could have written. And it's something more importantly based on my own papers. If I ask it to give references, it will look at the reference that I have used. It uses those references. It doesn't make up things. And with this, I think I finished. So just I don't have any conclusions. This is all a work in progress, and I'm just having a lot of fun with this. I think LLMs are great natural language interfaces to code, data, and text. Before we could do searches by keywords. Now we can do searches with concepts, semantic searches. LLMs are multipliers. Now I feel like I have a team of engineers around me. And this idea of digital twins, I think, are a very interesting possibility. I don't have to be there all the time for my students for technical things, at least. I can just tell them, there is this language model, knows all our everything in our group. So just go and ask the language model. Thank you.
Thank you, Miguel. It's nice to hear that we can tip ChatGPT and that it doesn't really cost us anything, in fact. So, Giacomo.
Yeah, Harry, thank you. Thank you, Miguel. It's a bit of a, maybe, for sure, it's a kind of abstract or philosophical, if you want, question that I had. We have been discussing, so what you explained, so you made a kind of summary of 4 days of basically of a conference, right, in your presentation, touching upon the different application of what we can do. But let me ask you something that so writing a paper, for example, right, as an astronomer, I write a paper, that's my experience. I in a classical form, let's call it classical, right? So I write, I struggle, I'm not a speaker, English not a speaker, so it's a struggling experience. I need to put my thought into in a narrative that is scientifically, solid. And then it's done, then I send to so at the end, the final product has been approved, I put it out. Since I have a vague feeling of achievement, so I feel like I'm happy. At least for me, I'm very happy. So really, I'm talking about so genuinely, not only professionally, but also as a human. I feel I achieved something, I learned, and honestly, the day after, typically, I'm also happy because of the product. But since myself, I try my best, but nothing I do is very revolutionary. Okay, so beyond so the sense of achievement. So what stays with me is how happy I am for having learned, for having grown, having achieved what I did. And the day that's what stays with me. What makes me feel happy, basically, what makes me feel that I'm becoming a better astronomer or more professional. And so I wanted to ask you, don't you feel that using these technologies might take from us a bit this happiness?
Yeah, I think I agree with you. I think it may take some away from us. I think it's in a way, in a sense, I think it's inevitable because it has happened always. I remember when I was a master's student, one of our professors used to tell us that programming was so boring because they used to program with punch cards, and it was a lot of fun programming with punch cards. That was real programming, no? And programming is becoming less and less technical, no? Now programming is almost natural language. So we always lose something with technology. And I also enjoy programming from zero. And now with these systems, I don't do much programming, or I don't have to do much programming anymore. A lot of this is done for me. So yeah, we are missing this sense of, like you said, of achievement. About writing articles, I still have to write the article because the system cannot write the article for me. It cannot get new ideas. But in my case, at least, it really helps me to get me out of a hole. So it's not, sometimes I trap in a local minima. No? I just cannot leave that local minima. And I cannot find the right way of saying that. And it's okay, how can I say this? And the cool thing about these systems is that if I ask that to ChatGPT, it's going to give me some generic answer that sounds like an LLM. But this one goes to my papers, it knows how I said that before, and gives me a suggestion. This basically, this is how you will say it. So we still have to do the science, most of it at least.
Yeah, but it's not exactly. I agree completely. But as I said, it's very ideological, or philosophical. But beyond doing the science, the joy of doing our job, the luck that is a beautiful job, is not only in doing the science, but also in the fact that every day we improve, we grow, we become, we learn. So I don't know. I agree with you. Also in coding, that can sound very boring sometimes because you get stuck. But even that can become. Or we were discussing that even making a pretty picture, a pretty plot. It can take sometimes 3-4 hours trying to adjust. But at the end, it's nice. I mean, see.
Yeah. No, I agree. But on the other hand, we can become much more productive. I'm writing a paper now on a method I developed. And the other day I was looking again at my code. I developed the code a few months ago. I was looking again at the code. I didn't recognize the code because it was so cool and so well written. Then I realized, of course, I wrote this code with ChatGPT. I could not write this code before because now I just tell it, write this code in Python, then write it in C, then write it in CUDA. I learned CUDA 15 years ago, and then I stopped using it, and it changed. I forgot CUDA, but I know the basics of CUDA, so I can ask it to write this in CUDA, and I know CUDA enough to see if it makes a mistake, not raising conditions. So, but I can write code that before I could not write. I would need a team of engineers around me to write this code.
Thank you.
Oh, thank you. Yeah, it was a repetition of the whole week. I'm sorry.
Yeah, so indeed, I mean, you're using your own set of codes and your own set of papers, which indeed allows to avoid errors and mistakes. But this is because you have a long experience in doing that. And that's why you can rely on that. So a young researcher would not be able to do these kind of things, or would have to rely on other people's work. And then we start to enter into the issue of plagiarism and copyright and all these kind of things. So that's why maybe this is something you can do, but which is not something that is available for everybody.
Yeah. Something also tell my students that they have to build their own libraries. No, when they're doing programs, they have to build the library of programs. They will also have to build their own library of papers to do this. But it's something that we also do. No, we all write programs and build our own libraries. So we build a knowledge base. The difference is that now we can access this knowledge base in a much more efficient way.
I see. Yeah, indeed. That looks like a great idea indeed. But you need indeed to build also this thing. And I guess students should still also make mistakes because that's where they learn from and not simply take the answer. So thank you very much, Miguel. So now we have a break until 4:40. So please use this time to fill in the questionnaires if you have not yet done so. You should have received by email the links to the 3 questionnaires. And then please come back by 4:30 for a very interesting presentation about ethics issues and for a final discussion with all the speakers of today. So for the people on Zoom, please make sure that you turn off your microphone and your video so that you do not appear on YouTube during the break. Thank you. So welcome back. I hope you had a nice break and you all filled in the questionnaires. So we will now have another invited talk, this time by Professor Christoph Lütge from the Technical University of Munich, where he holds the Peter Löscher Chair of Business Ethics. Professor Lütge got his PhD in 1999, and since 2019, he is also the director of the TUM Institute for Ethics in AI, and he has written several books on these topics. So Professor Lütge will talk to us about the ethical aspects of generative AI. The floor is yours.
Thank you very much for the introduction. Just let me reconfirm, how much time do I have, including discussion?
So you have 30 minutes for your talk, and then after that, a few minutes for your question about your talk, especially, and then after that, we have a general discussion with all the speakers of today.
Okay, great. Let me now see if I can share my screen. Normally, screen sharing should work. Why doesn't it work?
Today we had some issues. Giacomo is the specialist for that, so he will explain you how to do it.
There is also, are you using, it's just, first of all, thank you for being with us. Are you on the browser or on the application?
I'm in the application.
Okay, then it should be okay. But in case of problem, you can also, if it is okay with you, you can also send this to us and I can share it for you. That's also perfectly fine.
I'm not sure because it's very strange. I can press the share button, but I don't see. I'm not sure if it might help if I relog.
You can also try get in and out from the application.
Just very briefly, let me try.
Yeah, that's okay. Absolutely.
Yeah, we had to do it for the speaker before. So
yeah, that's the beauty of the, how you say, the beauty of the
technology
of life, right?
Exactly. That shows that we are not robots.
Exactly.
Yes, now I think you have to make me co-host again.
Yes, I'm on it. Okay, done.
Okay, and I have PowerPoint is here. Let me check. This is I know what the issue is. This is again. Yes. I know. One moment.
Yeah, please. In the meantime, I would like to remind everyone, please stay with us. We will have the discussion after the talk. And also, we sent around the form three links to three documents, to three questionnaire. Please take some time to fill them because we would like to publish then the results. Sorry.
Okay, can you see my screen now?
Yes, very well.
Okay, great. So I will talk about ethical aspects of generative AI and also about AI in general a bit. First, let me say, why is this such an important issue? And I know that, of course, that you have been talking about all sorts of aspects in this, in the technical area as well. But as you may recall, last year, there was a very important meeting, the G7 summit in Hiroshima, where not only the G7 leaders came together, but they signed a kind of common vision for the governance of AI, which is quite remarkable for all of these to get together on an issue like this. They shared a common vision and goal of trustworthy AI, saying also that the exact ways of achieving this goal might vary. So this is also remarkable, but in general, one would say this is the governance of AI and including, of course, the ethics of AI is an issue that is being recognized as important all over the world. And as you also know, there are different approaches to this. There are at least maybe 3 different approaches that we see at the moment. We see a US approach that favors more the innovation side, a Chinese approach which takes more step towards regulation, and it has already put in place some regulation which is only directed, of course, towards private companies, not state actors. That has to be added. And there's a third path currently, the EU path. And I will say a bit more about this later in the talk, and the current EU AI Act, which also concerns, very importantly, generative AI at the moment. Okay, but before proceeding, let me say a few words about my institute, the Institute for Ethics in AI, as it was mentioned already. And it might be interesting to know how we work and how we do cooperate with other actors and players. So there are some institutes which have been founded over the last few years. Our institute was founded in 2019, and unlike some other institutes of this kind, we work directly together with the people from technology, basically, with the engineers, with computer scientists, with medical doctors, and others. So in all our research projects, we have people from the technical side working together with people from the non-technical side, from ethics, from law, from governance, and others. And I think this is very important to approach today's problems in implementing AI. So these are some of the areas that we work in, like AI in the future of work, so AI in the workplace, and what ethical aspects turn up in this field. Towards AI and mobility, which is, for example, about autonomous driving and others. Medicine and healthcare, governance and regulation, and also sustainability. And here we also have a large project which was just finished that was concerned with Earth observation. For example, AI in Earth observation also has some ethical aspects to it, like, for example, privacy, data protection, but also biases that may play a role here. And just lastly, if you're interested in more about this, we have an online AI ethics course system that we built together with New York University. It's free to take online or just to look at some of the lectures. It's easy to find if you Google for it. So this is around, I think it has around 50 modules at the moment. Okay. So what about the ethics of generative AI? And I would like to say, first of all, there are both ethical challenges as well as ethical opportunities. And I think this is very important to say, because in many talks and papers that you read, there's a lot of highlighting the challenges. But I think the generative AI and AI in general holds a lot of opportunities in terms of ethics as well. I mean, not just in terms of business, those are there as well, of course, but also in terms of ethics. If you look at the use scenarios of generative AI that we have at the moment, these are just some of them, and I would say maybe we are already beyond this. There are the language models used in translation, in writing, in code writing, very important, of course, but also in genetic sequencing, grammatical correction, and so on. There are the audio and speech models for dictation, for voice recognition, dubbing, even composing and songwriting, although I would say there's still some way to go here. And very important now, of course, visual and imagery models, which are not just about illustrations, about pictures, but also about videos. Now there are amazing examples that we see right now, and also data generating models, which is a key aspect, how to create a synthetic data to train AI models. So what are some of the advantages, just to name one example, and maybe this is one that's not so familiar. to train and educate medical staff and doctors. Here, AI-generated patient models can help simulate, for example, surgeries and medical procedures. This is a concrete example from a program that has been run. This one at the University of Michigan, a generative AI model for simulating sepsis treatment. And generative AI was able to create realistic simulations of different health conditions, and so allowing people to practice in a controlled environment, like you have with pilots. So already for a long time, pilots train in the simulator. Of course, I'm not saying this is all the way, but this is one step towards becoming professional. But also, for example, for patients to help in answering certain questions, to enhancing their understanding of medical procedures, to help to engage with them and the medical staff. There is, for example, MedPalm2 by Google that received a very high accuracy rate in answering those questions. Also, the quality of care, enhancing the quality of care. Here, I would say, and I think we're definitely only at the start of this. I mean, we have had generative AI for less than 2 years now. It has the potential to revolutionize healthcare practice by supporting carers in everyday tasks and decision making. For example, recommending tailored risk considerations for patients based on the data that is available about their medical history and about the literature, of course, and assisting then in clinical diagnosis. For example, I mean, this is still quite simple, enhancing poor quality scans into high resolution images detecting signs of diseases. We know that for quite some years, I would say 5 to 6 years, AI has been better than even good doctors at detecting signs of diseases, cancerous cells, for example, in images. But also summarizing, this may sound simpler at the start, but summarizing the information that is available and creating follow-up needs for further care is something that is very important to caretakers, and which takes a lot of their time, summarizing, taking account of what is happening. If you can use generative AI to help you in these tasks, it can be of a great advantage to have it. Extracting data from medical records and generating structured health reports, of course, not just in the field of healthcare, but in others as well. This is there are very good examples of this. Helping with administrative duties. This may not sound so well sophisticated or sexy, but it's a huge help in everyday situations for many professionals. Also, and this is of course on a different level, a generative AI can help in the development of new drugs, designing new molecules, not just assisting in designing on the basis of existing molecules or data that we have, but also generating new ones. And then, of course, this is mostly a question of crunching huge amounts of data, but it's much faster and can lead to good results in many cases, much faster and better than the traditional methods we have. There are some examples here shown, and there are many more. And also the ChatGPT that we know is offering, in principle, an entire path throughout several steps in this process, from supporting clinical decisions to record keeping, management of medication, to medical writing and documentation, possibly also triage processes that we, of course, sometimes have. Here again, I would, of course, highlight this is not about giving AI any decision power, but helping to inform decisions by human beings, human doctors. Of course. So this is one example, and I could, of course, cite a lot more, maybe just one, because I work a lot on the ethics of autonomous driving. And if you manage to implement ethics to implement autonomous driving on a significant scale, you could reduce significantly the number of deaths on roads or the number of accidents in general, which is not just an economic advantage, but an ethical one. But of course, there are challenges and risks as well. So just to cite some of these, there's, of course, the old privacy problem. How about sensitive data that might be exposed there due to data access, which is not monitored, or not just access, but retention of these data? How long should these data be stored somewhere, held somewhere? What about third-party vendors that might breach here? What about the reliability of information? This is a huge topic, not just in some, but in almost all fields of generative AI. Generative AI is very good, and even, let's say, a few years ago, we would not have thought that this would be possible, and at least many of us. But of course, it produces a lot of definitely inaccurate, fabricated responses, hallucinations sometimes, but also simple mathematical exercises or logical exercises sometimes do not work and gives false answers. So what about this? How can this be? I wouldn't say how can it be corrected, because at the moment, I don't see that there's a magic wand that would help us to say, well, now it's fixed. But it's just a problem that needs to be addressed and hopefully improved. But how can we do that? And how can we also make data be more up to date? As we know, the original ChatGPT stopped having data after I think end of 21. Now current systems, also Grok, for example, uses data from now, maybe even live data that I'm not totally sure, but relatively up-to-date data. But this is a question that needs to be addressed. Then we have the question of biases, fairness and transparency, a key ethical aspect in all sorts of AI systems. In one important question is how do you and what data sets do you use to train your systems? Historical data sets that we have are often biased. Our past is biased. It's not possible it's not possible to ignore that. That's why today we often use synthetic data to train algorithms, but also those might have skewed data or biased outcomes in them in many ways. So we can go more into this in detail in discussion. And a very important issue is the question of intellectual property. And there are some lawsuits, famous ones, already underway. How much are those systems allowed to use existing data, and not just data, but also, for example, works of literature, works of art, works of science. And sometimes you find bits and pieces of larger bits of pieces of these works in the responses that generative AI gives. And I think this issue is not solved yet. So what is being done currently to address these issues, both in terms of ethics and in terms of governance now? And certainly what we would like to have is to keep the benefits and the opportunities, but not the risks. So ultimately, I would say the goal of this, and this is mostly seen in literature as well, the goal is to be trustworthy, to make AI, and generative AI in particular, trustworthy. Otherwise, users will just not use these systems, whether in healthcare, autonomous driving, or wherever. I wouldn't use an autonomous car if I don't trust it. So there are three pillars of trustworthy AI. I would say there is the robustness pillar, which is more about the technical side, which I will not go into here. But it's a very important one, and there's a lot of work being done in computer science, of course, about how to make these systems more robust and safe and secure and so on. There's the ethical side of it, and in the past, I would say at least since 2017, 2018, we have seen a number of efforts here to come up with ethical norms, ethical guidelines for these systems. First, it was more like general ethical principles. There were these 5 principles of the high-level expert group. There were others too. And then these systems, these principles became more concrete. And for example, I was part of several such groups which developed more concrete guidelines for specific AI systems. And I think it's still a very important aspect because it is not without truth. Some believe, oh, this is just about ethics. It's not so. It doesn't have that much bite. But without ethics, you can damage a lot your reputation, as for example, Facebook did with Cambridge Analytica, and others did as well. So I still believe ethics is an important pillar here, but there's the third one, the law pillar now, with a specific laws now underway or already at least enacted. But we also had others, like we have, for example, human rights treaties, conventions, and member state laws. But now we have and GDPR, for example, product liability directive, and so on. But now we have a regulation in the EU that was specifically put up for AI, the AI Act. And of course, you will have seen this. This was the way it went 3 years ago. There were first publications about the proposal, and there was a consultation period. We also took part in this. There were several positions adopted. The European Parliament adopted their position in last year, mid of last year. And then there was this kind of trialogue process between the Parliament, the Commission, and the Council, and it ended up, in a relatively short time with the AI Act coming into force now, actually just last month with August 1st, with a date of applicability, not immediately now, but in the nearer future. And companies, those that implement these, so that put these systems on the market, will have to deal or comply with the AI Act. So the AI Act classifies AI systems into several layers from minimal risk to unacceptable one. The unacceptable risk category is very small. It includes social scoring systems, like in China, as is being said. Some parts of facial recognition systems, but mostly those of surveillance of public places. But even that is sometimes contested now in the implementation. So it's a rather small group. The minimal risk group at the bottom is also it's rather large, as is mostly said, contested also. But the other ones, the high risk and the limited risk categories, are the more important ones, because there you wouldn't have either transparency requirements in the limited risk category, and conformity assessments for the high risk category, which includes not just systems in the field of law, but also, for example, those in the field of education, which there is some controversy about if that makes sense. But here, definitely, those systems that are supposed to be used, for example, in schools or other places, would need to undergo these conformity assessments, which are not yet developed, one has to say. So this is something that was just written in the text, but doesn't have any real backing as for now. And those systems will include risk management systems, data governance systems, or something about that, technical documentation, like with machines, with any machines, also record keeping, but in particular, one aspect is important, the human oversight. Human oversight, whatever that means, it will mean different things for different systems. With some systems, it might be possible to do it in live mode, whereas, of course, for example, with autonomous driving, that's not possible. But you still have to devise ways to put human beings in the loop at some point, point that makes sense, basically. And it's interesting what the AI Act says about generative AI systems, because when the AI Act first was proposed, these systems were not yet there. Suddenly they were, and the EU chose to include them. They use these words, like these concepts, general purpose AI systems, and foundation models. So foundation models and generative AI. They are saying that you have to include a number of considerations when putting these models on the market. Not when they are being developed, at least that's what being said. Also not for research. But the question is, can you separate these? Can you separate the development of these models from the implementation? So the providers are supposed to of generative AI, they are speaking about foundation models. They are supposed to design, test, and analyze, include methods for reduction and mitigation of reasonably foreseeable risks. This is not specified. This can mean a lot of different things. It is a very broad concept. It's supposed to achieve appropriate levels of performance, predictability, interpretability, corrigibility, safety, and cybersecurity. Again, this is not yet really specified. One can only say it leaves a lot of uncertainty about what can be done with these broad formulations. Technical documentation and quality management system. Maybe this is less important. But I mean, to put this into perspective, of course, the EU is not alone in the world. There are other players, and if we have already talked about China and the US. In the US, there is now the executive order by Joe Biden from last year, which, however, is not in the same sense legally binding as the EU AI Act. And some other important countries have taken positions here, like Japan, for example, also definitely leans towards softer AI governance rules. They are also saying they will not make them legally binding. India has basically said the same. Brazil says they are working on a law in this area, which is not yet there, as I understand, but it's proposed. And in Canada, there's another act on the way, as I understand. It's not so clear where it stands, as I know, but that also would be on a similar level. But as I said, in other areas, where China, for example, there is regulation, but it's only directed at the private sector and is not putting any limits on the state sector, which I think it's also not unproblematic. So coming to an end now, I think it's important to see that what is being done here. And there are three main critiques of what the AI Act does. One is that one criticism is that it might impede the EU's competitiveness and the innovation capability, because it defines AI in a too broad way. One could have done, and actually I find some sense in this. One could rather have gone for more specific regulations for specific areas. In autonomous driving, we need definitely this regulation. Without that, we will not be able to proceed. But in others, maybe we don't. The second point is that SMEs, so small and medium companies, might not be able to stem the costs of the risk governance. This is a very important point, especially in Germany. Small and medium, we have a strong Mittelstand, small medium companies and startups in the area of AI. They are very much worried at the moment that they will not be able to bear the costs of these compliances. And the third aspect is a very general one. Is there really this need to rush? As I said before, we haven't had a generative AI for more than 2 years, less than 2 years actually. Do we really know what are the real risks? What are the risks that need to be addressed? Should we really rush? Yeah, and there were several steps also being taken to urge the EU to adopt a more hands-off approach, but these did not work out. And last remark, we have seen just in a few weeks, actually some important development. The Draghi report, I think that should not be underestimated. The Draghi report on EU competitiveness said a number of things, but one important thing was that this was directed also to the EU AI actors, others as well, that they are now themselves, the EU is themselves saying our regulatory stance towards tech companies hampers innovation. And this is not just meant at the large players in Silicon Valley, but rather with this regulation, Draghi said we are actually self-defeating. That's what he himself said. We are killing our companies. And so especially our small businesses. So this is a point that I think will now be addressed also on the EU level. It will be seen now what comes out of that. I think, again, AI ethics is a very important topic. And this will definitely continue to be. However, the current legal steps that we are taking, I think, should really be addressed again, should really be looked at more closely so as not to damage the innovation force of EU. Because if we don't have any AI development anymore in the EU, this will also not help our ethics. Thank you very much.
Thank you very much. This was really a very nice and comprehensive overview of all the risk, the benefits, and the risk of generative AI. So that really was great. Are there any questions about this talk? Yeah, Giacomo?
Hi, yes, it's really rich and stimulating. I have plenty of questions, but maybe we can also see during the discussion. But first thing that came to my mind, so we discussed in the past days, so it is pretty clear for us as astronomers. Astronomy is a safe science in a sense, in the sense that what we do, even though we have a certain and quite high impact on society, and in fact, ESO has brought a report about the impact on society of astronomy, but still, if I as an astronomer make a mistake during my science, there is no big impact. But of course, the example that you showed us is, for example, the quality of care. This is really high, has a high impact. For the society. I was wondering, for example, so still in the past days, and in particular with respect to health, in the past days we had some talks from cognitive psychologists, and it seems that there might be, we don't know yet, but so that's me as an astronomer trying to understand, right? So it might be that there is some area of the way we communicate, the way we are humans, that can be affected by the use of generative AI. And I was wondering, in the example, so whether the European Union, or in general, there was a discussion of, for example, in the healthcare system, or in even the simple relationship doctor-patient, whether all this aspect related to human interactions, to which extent this can be affected and compromise maybe a bit the way healthcare works. So whether it was discussed, whether this can also have, there is a certain extent in which this can also have a risk on the system, while it can make it more efficient, but on the other side,
Yeah. Yeah, actually, this is interesting because in the past few months, I have been invited 3 times to medical conferences about to talk about ethics of generative AI, and I was very surprised. I thought they would be interested in ethics of I don't know, surgical robots, but no, they were interested in what does GPT, what do the LLMs mean for me, and what I see is they see a lot of opportunities there. Also, just simple ones like simplifying their administrative work. But it's true. Certainly, there are changes I think there are already now changes in the relation between doctors and patients. I mean, we've had that since the internet started, or at least in the last 20 years, I would say, that patients started to gather information on the internet and had their own opinion on certain things, and that changed the relation definitely. I think this is another step towards it, but yeah, I think there's no turning back to that. This is something that doctors probably will have to live with. But I see your point. Yeah.
Thanks.
So Dario?
Yeah, Hi. I'm interested to know from your presentation, you talk about ethics and G7 and you. Are you in contact with the Chinese ethical counterparts or American counterparts, and what do they think about this ethics about AI, if they exist? I don't know.
Yeah, so this is interesting since I was part of the ethical discussions in the last 7, 8 and more years. So I've really witnessed the development. For example, we've had the Beijing principles of AI in 2019. So the Chinese side also developed ethical principles for AI. And the issues there are, I would say, about 80% the same as those that we had here in Europe or other principles that were developed in the US. So I wouldn't say there's that much of a difference, but in some areas there is. For example, when it is about autonomy. Also, the Chinese side does not use the word democracy. Yes, that's true. And now with the regulation, there I'm more worried since there it makes more of a difference. Since, as I said before, the Chinese regulation is all about the private sector. But what then about the public sector, which is quite important, of course, and where, for example, surveillance issues can make a lot of difference, can do a lot of damage to people, and the government has a lot of power. And I'm also worried because some of the people in the West are seeing this as an example. Oh, look, China is regulating AI, so we should do the same. Maybe we should, but not because of the way that China is doing it. At least that's my opinion. So yeah, I'm worried here a bit.
Thank you. So May?
Yes, thank you for the fascinating talk. I actually have 2 questions, and they're somewhat related. The first one is, do you feel that the EU is in a good position to enforce the AI Act? And the other question is really, because I know nothing about this, but for small businesses, what is the cost of compliance? Is it like hiring lawyers, or what is the issue?
Yeah, the issue is about actually it will in many cases be just buying software, software that is being developed in order for you to comply with the EU AI Act. like we already have in many other areas. Anything with, you know, about the ESG criteria. And there, companies buy software, which is then often developed, for example, by the big players. And so they are able to sell more of their compliance software. And that is one cost. And then, yeah, sometimes also departments for compliance. So the big companies usually have compliance departments, and for them actually it's not such a big deal to say, well, we are delegating this to the department. They will tick some more boxes. This is eventually all about box ticking, but something that SMEs often don't have, or or need to build up, and that takes time and cost. Is the EU able to enforce that? From many conversations that I've had during the past years, they thought they had some, especially EU bureaucrats in Brussels, they thought they would have the power. I think they're now realizing that they don't have it, actually, to put it very bluntly. I mean, you can do it, but then you lose some of the cutting edge in innovation, and you lose, as we have some examples now already, where EU is losing the access to important systems. With Apple in the past few weeks and Meta, they have said they will not roll out certain aspects of their new AI software in the EU because of concerns of regulation. Because the EU is threatening them with fines of up to, I think it was 5% of global turnover, which is a lot. Yeah. And so they are just not risking this. And so I think, yeah, that's the point. But I don't think it will stop, of course, them from using these systems anywhere else.
All right, thank you.
So, but is there not a risk that there is then some kind of blackmailing by those huge companies towards the EU by saying, well, if you keep on this, then we don't come to you and it's your loss?
True. But what's the solution to that? What's the solution? But the blackmailing by those big companies, I would say it's not the only, and even not even the key issue. The key issue for me is the small and medium companies from our own region, and those are burdened with a lot of costs here, and they may lose the competitive edge, or just go elsewhere. We have already examples from companies. We have a lot of AI startups here in Munich, for example. A lot of these came out of my university also, and you can eventually relocate to somewhere else, even to London, for example, where they don't, as it looks, do not have these kind of, no, at least not these kind of strict regulations in the same way.
Okay, thank you. So, Andreas?
Yeah, I'm wondering whether there are any best practices that encourage humans that use AI to behave ethically. So I'm thinking about, say, the lazy doctor or the lazy astronomer who is reviewing a paper and using AI to generate the review, or the doctor who may just not really exercise his obligation to be critical and be, say, the last decision maker, but leave it up to the AI, and whether this is influenced perhaps also by the way in which results are presented. Say, if I have an AI system that is giving me the message that it is absolutely certain that something is true, I may not want to feel obliged to check the result. Whereas if it is presented as much more uncertain, then maybe I will do. So what is kind of this interaction, the human interface in the end?
That's a very good and very important question. I don't really have a good answer to that, but that's a point that I have been making in a few talks, since there are studies that show that ultimately, if you get a suggestion from an AI system, and in 90% or more of the cases, you just go with a suggestion. If it doesn't look just too ludicrous and Yeah. And so what should be encouraged is ways for the human decision makers to decide against recommendations if they have some basis for it. I mean, one of the aspects that I didn't talk about is the explainability one. So explainability means that, yeah, in principle, there should be the criteria according to which a system got to a certain result should be made transparent, should be explained. In principle, this could mean that a doctor, for example, gets certain data about their patient, or other decision makers would then see, okay, I don't trust the decision of the system because of the way it got there, and I don't trust this element, that element. I think this should be recommended more and yeah, promoted more. Yeah, this is all I can say, but it's not easy. It's definitely not easy.
Yeah, I would also think that, say, the amount of output that I get from the system, if it just gives me two recommendations, do this, do A, do B,
Yeah.
or whether it says, I think you should do A and B because of this and that. I think these symptoms of the patient are what is leading me to this decision. If that is included, that's a different basis for then saying, yeah, I believe this or I don't believe this. So are there then, say, best practices that encourage or that the developers of such systems to include information or how they should be presented to the human that is using them?
Yeah, actually, there are some good examples. We have actually a research project that was finished, I think, last year here in my institute, which was about how to address ethical issues in recommender systems for medical doctors. And this made use of a lot of best practice examples. So you will find it on our website. But this was indeed about exactly what you are saying. So what should be built into a system to not just provide the information, because there's a lot of decisions to be made. What information should be presented and in what way, and how many alternatives, and so on and so on. And if you give too much information, then of course then it's also this decider is also lost. So yeah, there are you can find them.
So Giacomo, you still have something?
Yes, I have a question, but maybe I can make if it's okay with you, Henry. I don't know. It can also be for the other extended to the
Yeah,
other.
I mean, I was just going to suggest that all the speakers, if you
This
can.
is a question that maybe I would like to expose to a bit the other speaker as well, starting from Professor Lütge and then going to the other, because we have been hearing in the past days that the use of generative AI and AI in general does have a cost in terms of CO2 footprints. And I was wondering whether at the EU level, or in general, if this has been taken into consideration, so how it will be. So can we think of an extensive use of generative AI in a sustainable way? And the other aspect is for the other panelists. So is it worth to know? So you know that when you are reviewing your paper through an AI, as a matter of fact, you're burning CO2, right? So is it worth to do that? Yeah, please.
Is this addressed to me or whoever? Maybe
I
someone
would
else?
say if you can start with this part related, which is interesting, related to whether this has been somehow played a role in the AI in the discussion within.
Yeah, I mean, I can maybe just briefly, but I would let others speak here. Actually, we are just about to start a new project in this field, because it got more important over the years, I would say. And it was not so much addressed at the beginning, the energy question. It becomes more and more important now. But yes, of course, you always have to see both sides of the cost and the benefit, basically. So, but I don't want to decide where you would draw the line, or where's the break-even point, or where you would say that no, it's not worth anymore. But it's definitely an issue. I don't think it's one that is impossible to solve.
So anybody else wants to answer to?
Yeah, well, I'm not an expert on this, but I think part of the problem right now is I think it's a temporary problem. We are using large language models. For instance, I use using models to solve problems in astronomy programming, but these models are huge models. They know medicine, law, everything. I don't need that. So right now we are using this big hammer to kill a fly. I think what is going to happen eventually is that these models will fragment into very specialized areas, and they will be much smaller models. Because I don't need to run a full ChatGPT to answer a question in astronomy or coding. I don't need to know English literature. So I think part of the problem right now is that we are using these monster machines that know this a huge amount of knowledge to answer very specific questions, but that is not sustainable.
Okay, thank you. Anybody else?
I would like to add, we are, in terms of like calculating the impact of AI, or even more specifically ChatGPT, we are sort of in a almost like theoretical struggle right now, because even though we are sort of aware of the effect for instance, training this model have on the environment, right? We can calculate roughly the training impact, actually calculating how much resources we use when just using them, when just normal people use them. It is quite challenging. It's not exactly, we don't have like for instance a agreed upon way of calculating exactly how to evaluate the impact, and especially we don't have comparisons tool. I think that's actually what we're struggling with. When you have a technology where I calculate its impact on the environment, you usually tend to make a comparison with sort of, well, what if the technology wasn't there, right? With the alternatives. That's not really possible with things like ChatGPT, for instance. It's because there's not like a single substitute thing. It's not like substituting a specific thing. It's like a completely new tool, right? And so it's really hard to actually compare what kind of, like, what the world will look like without that tool. And so to even understand whether, ChatGPT is in fact making things more or like less environmentally sustainable, we will need to have like a more clear comparison of what kind of tools, what kind of things we will do instead. And so it's actually kind of complicated. We know the training is extremely somewhat like extremely expensive in terms of time and tools and computations, but tracking exactly the effect of these tools in a more larger way, it's very complex.
Thank you. So May, you wanted to intervene?
I was actually just going to add that the topic of the carbon footprint of various astronomical tools is something that Nature Astronomy has been publishing a big series on. So if anyone's interested in having a look, I will post the thing in the chat. And frankly, if anybody wants to propose anything, please get in touch.
Okay, thank you. And in fact, while you are there, and because we were discussing these problems of indeed how the EU is going to implement the AI, we can also ask it at the level of editors, because you mentioned to us that you have indeed plenty of useful guidelines of what you can and what you should not do when using chatbots and LLMs in publishing or in reviewing and so. But how can you enforce these guidelines?
That is the million-dollar question. I mean, in fact, if you step back a bit, I think we have to, in general, take the author's word at face value. Like when somebody submits a paper, we assume that it's a legitimate and real piece of research, and we treat it as such. And I don't want to start being suspicious of everything that comes in. But at the same time, we cannot ignore that this happens. So it is a question, and I think somebody else was saying it's a cost-benefit analysis type of question where we have to think, right, what resources do we need to use for this problem? And I can assure you that, as a big publishing company, we do have a compliance department, and we do have, lots of different groups looking at this. It's just at the moment, there is nothing to announce publicly.
Okay, thank you. Fabio?
Yes, unfortunately, I missed all the presentations today and the beginning of the last presentation, which was very interesting. My question about that presentation is if you make a difference between AI in general and large language model in particular, because in terms of responsibility of taking actions based on the answer, it makes a huge difference. And the difference I see is that in the AI in general, in the machine learning system, you have no way to understand why the machinery came to some conclusions. For the moment, we don't have that way. Why in a large language model, with the right prompting, you can ask the steps, the process that came to that conclusion. And if you verify the information and verify that it's not only hallucination, you can take a decision or not. I don't know if the answer is, the question is clear.
Yes, I see your point. So you can trace back the steps of information where the system got it. That's true. So, but what was, I mean, that's what I would say. It's not generative AI certainly is another dimension of another development of AI. It's not, that's why I would say there is a new quality that generative AI has when compared to other types of machine learning, and it doesn't necessarily be better. So I'm not saying that, but I mean, will that be the same with all systems of generative AI? I'm not so sure that we can always trace those steps back, right? Or am I wrong?
Okay, let me make a practical case. So this is a real case that I read a couple of months ago, where a machine learning system was able to predict the mortality of persons looking at their X-ray, and it was extremely accurate, extremely. And they, of course, the doctors wanted to know why, how. And it came out that all the X-rays had some code somewhere, and a particular code was referring to an X-ray machine, a portable X-ray machine. So the X-ray was taken at home of the person. This meaning that the person could not move and go to the hospital because the person was about to die. So the machine came to that conclusion based on the code. They didn't care about the rest of the X-ray. And I don't know if it was an intuition from the doctors, but they came out to that conclusion. With an LLM, you could ask how, why do you say that, based on what scientific evidence? Probably we come to a system where the generative language model can talk to the other machine and ask and communicate somehow. But for the moment, this is the situation. So, and based on this result, which are accurate, doctors had to take a decision. So the legal aspects are another thing. So how do you see such case?
Yeah, I mean, you have to put a system in a context and in an environment where it gets the relevant information. If it doesn't get the relevant information or gets well, some piece of information that doctors don't have, or the other way around, then yeah, you have different results. But I mean, I understand your point was how is it different in terms of ethics, and there I see similar, but in some ways a little different aspects. That's true. For example, the biases, I think they are. It's basically the same issue. You can improve on it, but you will never get rid of it completely. There are other, I mean, there are, for example, the IP rights issue. This is most severe with the generative AI, definitely, since as you are saying, where we can more clearly see where it comes from, at least sometimes, and so the question is, what do we do about it? Is there something to be done about it? So. So I'm not saying what exactly the solution should be, but I think it should be addressed. So yeah, there are some things that are different about the system.
Of course, I don't expect a clear answer now because we all know it's something very new. So we are learning.
Yeah, true.
Okay, thank you. So let's maybe then change subject and go back to publishing. And in fact, I want to use my privilege as a chairperson to ask something that I asked yesterday in the chat and nobody answered. So it's likely a very crazy idea, but Giacomo said it yesterday. I mean, but now it's really the time to be heroic and crazy. So my question is, do we still really need to publish in English? Because with all these LLMs that can do, of course, automatic translation, why shouldn't we not let everybody write in their own language, and then we don't have any more advantage, so everyone would be equal? So anybody wants to tell me why this is a stupid and crazy idea? Yeah,
I
please.
don't think so. I think this is an amazing idea. We already see it. Don't remember the name of this. There is a streaming service, and they are already translating voice interviews from people. So, like, I like to listen to Lex Friedman. He interviews many people, and I always want to show this to family who don't speak English, but now they can, because now he speaks in English, but they listen to him in Spanish. So I think there is no need to write in English anymore.
Okay, thanks. May?
Yes, I also agree. I do not think that's a crazy suggestion, but it does depend on how much you trust the translation.
Yeah. But this could be, I mean, could this be the role of the editors, or this would be too much burden on the editors to put that there?
Well, I imagine if we had the right tools that could just, take a manuscript in any language and translate it into English, if we could trust that translation, and if such a tool were available, I don't see why we wouldn't want to look into that.
Okay, so maybe this is the future then. So I think we have to soon conclude this wonderful day and this wonderful workshop. So I would like to finish by a tour de table, where I would like to ask all of the speakers of today if they could give a few concluding words and tell us maybe, or if they can say something else if they prefer, but maybe they can say what they see as the biggest risk to use generative AI for astronomers and what they see as the biggest advantage. So who wants to start?
I can start.
Yeah.
So I actually want to make a comment to May. So I think one way of addressing this problem of publishing with AI is transparency. If everybody says, I haven't published a paper yet with these tools, but I will say in my papers that I use this tool for helping me with the writing. So I think that is a step forward. No? We are at least acknowledging that some people are doing it already. So the risks of using AI in astronomy, but there are many. It's like Giacomo and Henry already commented after my talk. We are really missing something where we are using these tools. In my institution, we have been discussing already for a few years about the use of a library, because libraries are disappearing from many institutions. Now we have everything online. It's going to be the same with the large language models, but the library is a place where you go and you're looking for a book, but on the way you find other books. You find new things that they were not in your mind, no? And then you learn something. So I think one problem with these language models or in general artificial intelligence is that they make everything so easy that we become lazy. We will be less exposed to new things. For instance, the system that I'm developing, I have to update it constantly, or otherwise it will not know about new papers. It will only repeat what I already did and what I already read. But that's not how it's designed. So these are the one of the risks that I see, at least in my work. And advantages, but in my case, I think it's very clear. It allows me to have a team working for me. It does a lot of things that before it will take me one afternoon, I can do it now in 1 hour.
Okay, thank you very much. Simone, do you want to intervene?
Yeah, I think, at least in my opinion here, the biggest risk is actually in the sort of mass production of fake data and fake articles and papers. I do think that we're already seeing some of the effects right now, but if things go in the direction they're going right now, there could be a strain on the way that research is shared and the research is evaluated. However, I don't know that this is the worst thing the AI can do, as much as it's perhaps just an indication that the way we were evaluating and sharing research was perhaps not working. So I do think that, and I think we already have some evidence of this, AI might have a negative effect in publishing research, because it's going to be a lot easier for to create entirely fake papers full of fake data and fake experiments. But I do think, again, maybe that challenges is the way we think about research and the way we should think about research. And so perhaps it's just in response to AI, we're just going to have to find smarter ways to share our research. And I think the potential is really just on sort of like completely the other hand. I think AI is already making the act of research a lot easier. When it comes to astronomy, I do think that the community is big, but it's not nearly as big as other scientific communities, like if we compare to computer science, for instance. And so very often it's actually quite a small group of people that is working on very specific issues. And then it becomes really hard for people to keep up to date, for instance, on the huge amount of packages that are coming up for like different programming languages, for instance. I do think, for instance, in my work and the work with astronomers, just using ChatGPT to find out about new packages or new tools that have been developed and astronomy just cannot keep up with, because that's their main job. I think it can be very, very helpful. And so I do think that in terms of finding new technical tools and being able to learn new technical tools faster, that's really where the strength will be.
Okay, thank you. Professor Lütge?
Yeah, I'm very curious to see how it develops in the next years, since, as I said several times today already, we've seen generative AIs for less than 2 years. And I think it was a very good point that was pointed out by Miguel. Is it really generating anything new, anything groundbreaking? I mean, as scientists, we would like to have something new and something groundbreaking, and also as good artists, for example, we would like to really the groundbreaking art. Of course, not every art, not every science is groundbreaking, but still, I think sometimes we would like to have it. And can ChatGPT? I don't think it can do it. I don't think it may be able to help, certainly in a lot of aspects, but I mean, at least I am not worried now that it will completely make us all obsolete.
Yeah, that's good news. May?
Yeah, I mean, I agree with all the others. What I would personally love to see is ChatGPT take some of the more tedious tasks that we do, so that it would give us more time to think and be creative and really innovate. But the risks, of course, is that because it was trained on the internet, which is of course, based on very, historical and very biased opinions. Yeah, that just the perpetuating these biases and baked in inequalities is something that really worries me.
Okay, thanks a lot. And I want to thank all the speakers for their great talk and for participation to this discussion. This was really very helpful. We learned a lot. Giacomo, do you want to have the final word to the conference?
Yes, I just to thank everyone, all the speakers of today. As it happens already, I mean, it's extremely high quality of talks and extremely friendly and balanced and respectful discussion. This is really what we were looking for, and we achieved that. I'm very, very happy for that and grateful to all of you. Thank you, Henri, for moderating. Was great. We have the title for our next conference, The Obsolescence of Humanity. Is it a risk or not? But it's really was really stimulating week. And all the talks and the material will stay online on YouTube, so you can watch. We will. I mentioned that before, so I need to keep up with the promise. We will try to formulate the summary of the conference in a paper. It will take some time because there is so much content. But we will try to do this. In that sense, it would be very helpful also if people can fill in the questionnaire that we created. That will help us to give some solid numerical, some statistics on what happened in these days. But anyway, yeah, I thank you all, and yes, and see you next time. Okay, and yeah.
Okay, thank you.
Thank you.
Bye-bye.
Thank you very much.
Thank you.